after we'd been polishing plate for a year or two, around 1978, we began to wonder how we could have a better internal system that would ensure surface roughness consistency. We recognized that simply doing the same thing every time to a plate would get you close, but starting material surfaces vary greatly, and as a result, inconsistent starting surfaces often yielded inconsistent results. The same applies today. It was about this time that we discovered a machine that would read surface roughness and allow us to gain a much better surface consistency, plate to plate, allowing us to make adjustments mid-process to dial in the end results. That machine is called a profilometer. They've come a long way from our first one, something that looked like an old portable record player. It cost a lot more money than we ever imagined spending, but it differentiated us. It is now embedded in our work every day. Every polisher worth his salt must employ a robust use of a state-of-the-art profilometer and document its use in process to ensure consistent results. We like to say if a plate reads 25 RA in Philly, it's going to read 25 RA in Texas, and everybody sleeps better at night. This delicate little machine does a lot of work in a 3mm sample. Essentially, a diamond stylus is dragged across a given sample length, perpendicular to the grain, and literally counts every scratch, measures the height and depth of the scratch, and computes an arithmetic average after trimming off the high and low. The product of all this is a single number expressed in either the English or metric scales. Technically, the readout is expressed in the Greek sign mu inches or mu meters. These two can be converted back and forth using pi as a conversion factor. And right now I'm wondering if my 7th grade math teacher would be slack-jawed for giving me a D in 7th grade. But he's not here to judge. Some of you may be familiar with the RMS scale for surface measurement. When we started using this machine in the 70s, that was the only scale used. It was at that time how machinists measured cutting roughness, and was replaced in the 80s with RA. Should you run into an RMS scale, do the conversion by multiplying 0.9 times RMS and you'll get RA. It's not exactly, but close enough to get this safely inside the spec. The Achilles heel of this smart little machine is that it can be fooled, and it probably is every day in the polishing market. The profilometer is only as smart as the process that was applied. That means if a final finish is applied over top of several other coarser belt grains, the profilometer can give a reading reflecting the finer scratch. In fact, if you look closely at these finishes, you'll see grain structure from the initial grind belt, the interim mid-level belts, as well as the final finishing belt. This is commonly referred to as a confused finish, and although the appearance may be found acceptable, the continuity of grain can be highly problematic when it comes to the intended performance of the finish. If at this point you are reaching for your pause button, but you're wondering why this matters, stay with me. A finish that has varying sizes and depths of grain in the final finish is one where the process did not succeed in removing the previous grain scratch. Proper belt sequencing was not performed, or pressures and other parameters overlooked. Finishes rushed in processing will not yield predictable performance results. In fact, if electropolishing is applied to this type of confused grain finish, the results will be unpredictably high and unsuccessful. The takeaway from all this is that the engineered function of the finish may not be realized unless care and focus has been applied to the process that created it. Never be afraid to say to the polisher, prove it.